So we have our geometric series and we have an arithmetic series, but we also have just generic series that's neither geometric nor arithmetic. I've got an example of that here on the board. But our main goal for this video is understanding what is called summation notation, okay? That's what we're looking at here. On the last videos, you saw me list out our series. Term 1 plus term 2 plus term 3 plus blah, 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 term 27. That's not going to happen every time. These are easy, compact ways to represent our series in summation notation. The scary part, you guys are seeing, we got a shadow there. Whee! Okay? What we're seeing here, this is uppercase sigma. Okay? It's a Greek letter. It's uppercase. The lowercase, you guys used it with our standard deviation. Okay? But now we're using the uppercase sigma, which in math just means sum. Okay? So all this is saying for this one, add up all of the terms in this sequence from the fourth term to the 18th term. That's all this says. Okay? This one over here is saying add up all of the terms from the second term to the 10th term of this sequence. That's all. That's it. Okay? Looks maybe scary, but it's not. It's super, super simple. It's giving you everything you need. Okay, so this first example, this isn't arithmetic or geometric, so we don't have formulas. We don't have shortcuts to find the sum. So what we're going to have to do is we're going to have to find each and every value. That one's for you, Holly. Don't worry about it, guys. It's from a friend. Okay? We're going to find each value, and we're going to just add them up. How do we do that? Well, I need to know the third term. So I'm going to take that and I'm going to plug it in. 3 squared is 9, times 2 is 18, minus 1 is 17. Now I'm going to plug in 4. 4 squared is 16, times 2 is 32, minus 1, that's 31. Okay, and I know that this isn't geometric or arithmetic because we're squaring it. Okay, when it's arithmetic, our variable has an exponent of 1 only. That's what makes it arithmetic. Okay, it's linear. Here, my variable is in the exponent. That's what makes it geometric. That's how we can tell the difference. Okay, now I plug in 5. 25 times 2 is 50, minus 1 is 49. Plug in 6. 6 times 6 is 36, times 2 is 72, minus 1 is 71. And then I plug in 7. 7 squared is 49, times 2 is 98, minus 1 is 97. So here are my 5 terms, and I'm going to go ahead and add these all together. I need my calculator right here. Okay, so I've got 17 plus 31 plus 49 plus 71 plus 97, and my total is 265. So the sum from third term to 7th term of this sequence is 265. That's it. Okay? So with it being arithmetic, we have our formula. So if you remember, we have S sub n equals n over 2, first term plus last term. That's it. So I need to know what my first term is. To know my first term, I'm going to plug in 4. So when I plug in 4, 4 times 3, that's 12, minus 5, that's 7. And then I need to know my final term. I get my final term by plugging in the 18. 18 times 3, that's 54, minus 5, that's 49. Then I need to know how many terms I have. To figure this one out, what I'm going to do is I'm going to take 18, my 18th term, minus 4, my 4th term, and I have to add 1 back on. Okay? So 18 minus 4 is 14, plus 1, I have 15 terms. So the reason I have to do that, let's take a look back here real fast. If I do 7 minus 3 to figure out how many terms I have, that's saying I have 4 terms. But look, I plugged in 3, 4, 5, 6, and 7. That's 5 terms, but this is telling me 4. What happened is I actually subtracted this third term, so we have to add it back in. Okay, so we take the upper minus lower plus 1. That tells me how many terms I have. So now I just got to plug it in. So now I have 15 over 2, 7 plus 49. So 7 plus 49 times 15, divide that by 2, I times by 2. So my sum here is 420. So if we were to go through and find every term, the 4th, 5th, 6th, 7th, 8th, 9th, 10th, all the way up to 18th, add them together, we're going to get 420. Okay, so this last one, this one's geometric. So we have the 2 formulas for geometric, depending on which one you like. I'll go ahead and use the one where I said it might be easier if we didn't have the list. So remember, in the last video when we talked about geometric series, this formula required me to use logarithms. So it might make you think, nah, I'm not going to use that one ever. But here, it's actually really easy. So here, I need to know my first term, so I'm going to plug in 2. 2 minus 1 is 1, 3 to the first is 3, times 4 is 12. Okay? Then I need to know my common ratio. The ratio is always the piece that's raised to the exponent. So here I can tell that my ratio is 3. Then I need to know n, how many terms I have. So again, I'm going to take 10 minus 2, which is 8, plus 1. That tells me I have 9 terms. So now I go ahead and plug that in here. So that's going to give me 12 times 1 minus 3 to the 9th over 1 minus 3. So I'm going to do 3 to the 9th, 1 minus that, times it by 12, and then I'm going to divide it by negative 2. And I get 118,092. That's it. Okay? So I use this to pull out the pieces of information I need. Let's go ahead and use that second equation just so we know how that works. So this one was a sub 1 minus a sub n times r. So here I need my final term for this formula, which means I have to take 10 and plug that in. So 10 minus 1 is 9. 3 to the 9th is 19,683 times 4. So now my equation is 12 minus 78,732 times 3 over 1 minus 3. So I plug that in, and I get 118,092. Same answer, different formula. Just depends on what pieces we pull out. Okay? Hopefully that makes sense. If you got questions, you know where to find me. I live here.